There's another way that we can think about this triangle and these outcomes. So before we were thinking about the paths that we could end up on, but what if we thought about one of those outcomes, either red or yellow, as being the one that we want to focus on? And let's say we want to focus on yellow here. Well, on this first path, how many yellows are in there? I don't see any. So we have 0 yellows here. What about the second path, or the second dot? We have 5 paths to get there. Well, let's take one of them. Well, there's 1 yellow, but once we do that yellow, we're with red for the other 4 flips. So, and we could go down any of these paths and see that there's always just 1 yellow and the rest are all red. So here is the 1 yellow situation. And we can keep going and see, well, this is a 2 yellow situation. And it turns out that this corresponds to 3 yellows, this corresponds to 4 yellows, and this corresponds to all 5 being yellow. So we could summarize this information in a graph. And that's what I have over here. So on the horizontal axis, the x-axis, I have the number of yellows that we end up with when we run through this experiment, flipping the coin 5 times. And on the y-axis, the vertical axis, I have the number of times this comes up, also called the frequency. So the height of these bars are going to depend on how many paths from our triangle we could get to 0 yellows, 1 yellow, 2 yellow, 3 yellows, and so on. So if we come back over to our triangle, 0 yellows, well, there was only one way to get 0 yellows. We had to get red on all 5 flips. So the height of this bar goes to 1. When we look at 1y, well, there were 5 ways to get there. So the height of that bar is 5. 10 ways to get to 2, 3, 5 ways to get to 4, and 1 way to get to 5. So these are the kind of graphs and, I guess, models that statisticians use to describe real life situations. Okay, so we see this nice symmetry in the graph. We saw it there, but now we can visually see it in the graph. And if I were to draw a smooth curve through this, it might look something like this. This was for a nice, simple case where both red and yellow were equally likely. But in real life, we're not usually dealing with equally likely events, so things are more complicated. Statisticians use models like this to try to describe what's happening in samples of people or animals or things. So let's think of an example. Let's say that we wanted to take a sample of 5 students from your school and ask them if they like ice cream. Do you think that people are going to be 50-50, as in half the people are going to say no and half the people are going to say yes? Probably not. I'm thinking that ice cream is pretty popular. So let's say that about 80% of the people in your school like ice cream. And suppose that we take a random sample of 5 students from your school and ask each of them, do you like ice cream? And yes would be yellow and red would be no. Do you think our picture would stay the same? Well, if 80% of people like it, we're probably going to end up with more people than not saying yes to that question. So our curve or our graph here is going to change a bit. It's probably going to be highest up here, more yeses, right? Okay, so if we expect that lots of people like ice cream, we're going to expect to see more yeses than nos. So the curve was highest over here, it's going to be shifted over here a little bit, so it might look more like this. And if you can think of a situation of maybe a food that people typically don't like, and we were going to draw a graph of the distribution of yeses in that situation, we'd have this middle graph, the red one, shift down So we'd be more likely to see fewer yeses. People don't like something. Okay, so if you want to try this on your own, try this experiment and draw a nice picture to see what happens to the graph, you could, rather than flipping a coin like we were before, you could take a die, six-sided die, and one of the sides you could say that that's your yes, and the other ones you could say they're no. So let's just say that one is our yes, and the other ones are all no. So that would give one a probability of 1 out of 6 sides to be the one that we get, and then not 1 is going to be everything else, so 5 out of 6. Okay? So let's see what we get. We get a no, right? So you could do that. Repeat this. So say if you wanted to do 5 rolls and then record the number of yeses each time, do that a number of times, and then graph your results. You could see what happens when you skew that probability. So if we come back to this picture then, remember we've changed the chances. So what one outcome is going to happen more often than the other one. Remember before we had this coin, it was a 50-50 chance. So we flipped it, and half the time we'd expect to go this way, and the other half we'd expect to go this way. But now when we switch to the die, we're saying, let's say red is going to be when we roll a 1, and yellow is going to be everything else. So these don't have the same probability anymore. This one's more likely. So what I'm going to do here is I'm going to say, well, it's more likely it's going to get a thicker line. And if I did that to all the yellows, that's just meaning that we're more likely to flip a yellow than a red based on this. You'll see that those counts that we made up before aren't going to work anymore because yellow's coming up more often. We're going to tend to see more yellow in our flips or rolls. So we're going to tend to see more non-ones. So rather than just being nicely symmetrically distributed this way when everything's equally likely, all the outcomes are going to be, all the paths are going to be shifted toward it this way, and there's not going to be as many here. So if there's only a 1 in 6 chances of ending up with red on each roll or flip, it's going to be really unlikely to end up with 5 reds. Another way to think about this, well, let's say we had a funnel up here. We're going to pour some water in here, and pouring water in, and these are pipes. So this pipe is wider. So the yellow one is there's going to be more water traveling down that pipe than the red pipe. So if we were going to collect this water, we better not make a mess, in some containers down here. So every dot at the bottom has a container. Which container do you think would be the most full? Well, more water's going down these pipes, so probably these ones, right? We're getting less and less full as we go, and here probably wouldn't have very much at all. If you were going to put these in a bar graph now, here's a smooth curve that would kind of match that bar graph that you'd make. So the peak, the higher water levels would be over here rather than the middle as before.